Determine without using a calculator the value of cos A. So let's go ahead and take a look at what is happening. So we have a point P, which is what we usually have, right? And then on this point P, obviously we have the x and the y. The x happens to be -3 and the y value is -4. Why don't we find the hypotenuse? Why don't we find r from the get-go? So if we do that, r squared plus, well, not r squared plus, but r squared should be equals to x squared plus y squared. So r squared will be equals to -3 squared plus -4 squared. Should be easy to see that r is actually equals to 5. So we have our x, our y, and our hypotenuse. -3, -4, and 5. Now let's go ahead and solve our equations. We are looking for cos of A. So cos of theta is equals to the adjacent over the hypotenuse, right? The adjacent is usually the x and the hypotenuse is r. So in this case of ours, we're going to have cos of A being equals to -3 over 5. Okay, and then 5.1.2, we have cos of 2A. This is very typical that 5.1.1 will be pretty much straightforward, and 5.1.2 we have these kind of trig ratios. We have cos of 2A. It is very typical, but we just need to know that cos of 2A is equals to 1 we just need to recall that cos of 2A is equals to 2 cos of A squared. Cos of A squared, let me just rewrite that, cos of A squared minus 1. So do we have cos of A? We do. So we're going to have 2 cos of A is -3 over 5. We square that and subtract 1. So let me just put that in my calculator and not complicate my life. So 2 multiplied by -3 over 5 squared minus 1. That is -7 over 25. So we have -7 over 25. Okay. And then the equation that follows, 5.1.3, we are determining the value of sine of A minus B if it is given that sine of B is equals to 4 over 5, where B lies between 90 and 360. Okay, so let's take a look. We know from the basics, right, that sine of A minus B is equals to something. So the best thing to do with this kind of equations is to not write the formula from your head. You have the question paper, copy it down. So in this case, we will have sine A cos B minus cos A sine B. Okay, so we have sine B. It is given to us, right? 4 over 5. And then what else do we have? We have sine B, and we have cos A. We have cos A from the question above. So we have sine B and cos A. So what is there to worry about? We need to find a way to find sine A and a way to find cos B. So let's think about that and see what happens. We are given that sine of B is equals to 4 over 5. Sine is equals to the opposite, which is y, over the hypotenuse, which is r, right? So we can find x using that. We can say that x squared plus y squared is equals to r squared. So x squared is equals to 5 squared minus 4 squared. So x squared is equals to 9. X is equals to plus or minus 3. So there we go. We have plus or minus 3. We have a decision to make. Is it plus 3 or minus 3? That's where these information comes in handy. So B range is running from 90. So from 90 is somewhere here, right, to 360. Yeah, that's where B is running. So what is the okay, so let's just sketch. Let's just sketch, because I don't want to explain too many things without sketching, because it will become a bit troublesome. So we have our Cartesian plane there. We have y. Y is 4, right? So y is right here. We have 4. And then our x, that's what you're looking for. Is it plus 3 or minus 3? Okay. Our angle is between 90 and 360, right? So we can take x as minus 3. So there we go. We have x as minus 3, and then our r is going to be 5. Okay. So there we go. We can have that like that. So that will help us with sine A and cos B. So sine A is from the diagram we started with, right? So sine A should be opposite y over r. So sine A y, we said that it is minus 4, right? And r is 5. And then what about cos? Is it cos that we are worried about? Cos of B. Cos of B, it is going to be x over r. So let's figure out what that is. X minus 3 r is 5. So there we go. We have sine A and cos of B. So sine A minus B is going to be equals to sine A, which is let me take a look. Sine A, sine A is y over r, right? So minus 4 over 5. And then cos B is minus 3 over 5. And then we have minus cos A. Cos A, we calculated it in 5.1.1. It is, let's see, okay, let's see, minus 3 over 5. So we have minus 3 over 5. And then what about sine B? Sine B, cos, that is cos A. What about sine B? Do we have sine B? Yeah, sine B is 4 over 5. So we have 4 over 5. Okay, so let's take a look. Let me just put that in my calculator and not complicate my life. Minus 4 over 5 minus 3 over 5 minus 3 over 5 multiplied by 4 over 5. I get 24 over 25. So yes, that's what we end up with there. And then 5.2. Yeah, 5.2 is quite a beautiful equation. 5.2 is quite a beautiful equation. Let me show you why I say that. So if cos of alpha is equals to P, express the following in terms of P. Yeah, we have that expression there, right? But let me just show you something. Let's slow down a bit. Okay, we know that sine of 2x is equals to 2 sine of x cos of x. So from this, it should be easy to see that sine of x cos of x is equals to sine of 2x over 2. So I want us to apply this idea here, right? Because here we have cos of what is inside the brackets here, and then we have sine of what is inside the bracket over 2, right? So sine of x cos of x is equals to sine of 2x over 2. So we want to use this in order to answer this question. So in our case, sine of 2x in our case. So we have sine of, in our case, we have, let me open a bra first. Okay, we have sine of 2, right? And then x is alpha over 2 minus 45. This is what we have in our case. Everything divided by 2, right? And then this is equals to sine of 2 and 2. I will cancel out, right? We're gonna be left with alpha minus 90. Everything over 2, right? So we can substitute this back here, right? Because this thing is equals to sine of x cos of x, right? So we will say that on the numerator here, we're going to have sine of alpha minus 90 over 2, right? These two, and then everything divided by, let me write that again, everything divided by 2, these two, right? So this is going to be equals to sine of alpha minus 90 over 4, right? So what is sine of alpha minus 90? Sine of alpha minus 90 is equals to minus cos of alpha over 4. So this is where 5.2 ends up.